All right, kth smallest element in a sorted matrix. So they give us a matrix where all the rows and columns are in ascending order, and let's just say k is 8, and we pretend that that matrix is like flattened out into like a single array with all the elements are sorted. The eighth element would be right here, 13. And note that there can be duplicates. So how we're going to do this is we're essentially going to binary search for that kth value. So we're going to binary search for the number 13. And the way we'll know whether we have the correct value for k, or not for if we have the correct kth value, not k itself, is if we want the smallest value where if we were to count all the elements in the matrix that are less than or equal to this value, that count is at least as big as k. And the reason is because, if you have less than k, well, then that means we don't have enough elements. And if we have exactly k, well, then we know we have enough elements, but we need to find the smallest value that satisfies that. And let me just go through an example to explain what I'm saying. So let's pretend I have this matrix here. And this is a different example, but so I type this out, and we have this matrix, and let's just say k equals 7. So we want the 7th value if this was all sorted, right? So I just flattened it out. The 7th value would be here, 13. Okay, so let me write that down. Kth value equals 13. And we're going to binary search for this number, the 13. We're not binary searching for 7, we're binary searching for 13, the actual value at k. Okay, so how we're going to do it is we're going to take the minimum value in the matrix, which is 1, and we're going to take the maximum value in the matrix, which is 15. And the midpoint would just be 8, right? Because 15 plus 1 is 16, 16 divided by 2 is 8. Okay, so this 8, this represents our kth value that this is our candidate that we're going to try. Well, we look at all the elements that are less than or equal to 8, or to 8, and there's only 1 and 5. Well, if k is 7, and this is only 2 elements, we don't have enough elements to satisfy k. So we have to increase our midpoint, right? So we're gonna keep searching, binary searching for this kth value, and eventually, we'll have 13. And let me show you what happens when we have 13. So let's just say eventually we have mid is 13. Well, we're gonna end up saying, okay, all these elements here are less than or equal to our kth value, our candidate kth value here. And notice that there's a lot more elements than k, right? So this was probably like, what is this, 9, 10, 11, 12? So there's 12 elements here that are less than or equal to our candidate kth value, or our midpoint. But we have to be able, we have to mark this as saying like, yeah, this is a fair kth value because there are at least k elements. Because the reason there's more than k, so k was 7, but here we got 12. The reason is because of all the duplicates. So we have to account for that, and we just say as long as this mid element, as long as all these elements are less than or equal to this, and it's greater or equal to k, then that is a possible kth value. However, what if before we got to before our midpoint was 13, what if it was 14? Well, 14 would satisfy our little condition of where, we want some value that gives us the number of elements that are less than or equal to our candidate kth value, but that count is greater or equal to k. But again, we want the smallest possible value to satisfy this, which would be 13. And the reason that works is because let's just say we took 12. And, if we try it out, if we took 12 as our midpoint, and this is our candidate kth value again, well, then we're only going to grab these elements, which is, what is that, 5 elements, and 5 is less than 7, or k, it's less than our k. So this can't possibly be our answer because we can't even grab a 7th element out of this. So that's why we need the smallest possible value that satisfies k, essentially, or greater or equal to k. Okay, so let's actually code this out now that I've explained it. And there's a little, I'll get to it later. Let's just type out that part for now, the binary search. So what do we want? We want the minimum value. So min matrix 0, 0, This is our smallest value because, again, the rows and columns are in ascending order. And we want the maximum value. So that's just going to be matrix.length minus 1, matrix.length minus 1. Okay, then we want to say while, oh, you know what, let me do low and high so it looks more like a binary search. But, you know, I'm still starting out with the min and max. Okay, so while low is less than or equal to high, if, oh no, we need our midpoint. So int mid equals low plus high minus low. And I just do it like this to avoid the integer overflow. So we found our midpoint, and now we want the number of elements. So int, let's just call it count. The number, so this would be the number of elements that is less than or equal to our midpoint. So let's just call it get num elements. I'm going to pretend we have this method written, but we don't. We're going to write it later. So get num elements less than or equal to mid, something like that. So value, so I don't know. We'll just leave it like that. Okay, and then we're going to pass in matrix, and we're going to pass in our midpoint. Okay, so now this again, this represents the number of elements that are less than or equal to our candidate kth value. Okay, so if our count is greater or equal to k, so we satisfy the condition where the number of elements is greater or equal to k, then we want to say that this is a potential, we want to say that our mid is a candidate, is a possible kth value. We don't know for sure yet because we need to try smaller values than it, right? Because we want the smallest possible value that satisfies this condition. So let's make a variable up here. Int kth value equals, I'll just initialize it to 0, but it doesn't matter what we initialize this to. It'll get overwritten no matter what. So we're just going to kth value equals the midpoint. And now we want to try smaller values that satisfy this condition. So we want to say high equals mid minus 1. Okay, so that'll lower our midpoint, or that'll lower our range of where we're searching. But, you know, if nothing else works out, that means that we found our kth value already. So let's keep going. So else low equals mid plus 1. Okay. So we've done our little binary search, and all that's left, oh, well, I got to return the kth value. And now all that's left is this method right here. How do we actually get the number of elements less than or equal to this midpoint? And again, this is like a candidate kth value, right? Okay, just making that clear. Okay, so let's go ahead and write this. And there's an efficient way to go about this. So let me just type it out really quick. So private, what is it supposed to return? The count. It's going to take in our matrix. And it's going to take in the midpoint. Or we could just say, we could call this kth value. But this isn't the actual, this is a candidate kth value. You know, we're just checking, you know, maybe it is, maybe it's not, but I'll just make it that for now. I'm just going to name it like that. Okay. So, what am I trying to do now? So I'm thinking about how to explain this. So our matrix, our rows and columns, they are in ascending order, right? So like if we start at the top left corner and we go down into the matrix, you know, it's just ascending. And if we go from the top left corner towards the right, it's still in ascending order. But now let's say we start from the bottom left corner. If we start from the bottom left corner, you know what? Let me explain this with a whiteboard. Let's say this is my matrix. Oh, give me a bigger pen than that. Come on. Choose that. There we go. Okay, let's just say this is my matrix. And this is my bottom left corner. If I go in, let's say in this direction, this would be decreasing. And if we go to the right, this would be increasing. Okay, I'm not gonna write it all out because I'm slow at writing with my mouse. But anyway, and we're saying that we're gonna start here. So this is, I'm saying C for cell. So if we start at this cell, what if we check, and then we have some like kth value. So write that really quick. Let's say and this is our candidate kth value that we're trying out. And we just want to know how many elements in this matrix are less than or equal to this kth value. Okay. So we want to know, is this cell here less than or equal to this kth value? So we could just say C less than or equal to our kth value. And C represents cell here, not column. Okay, cell. So is our cell less than or equal to our kth value? Well, if this is true, let's just say that this was true, right? Hypothetically. Then that means because these are decreasing, everything in this direction is decreasing, right? Well, then we know this entire row we can actually count this entire row as the number of elements that contribute towards like the number of elements that are less than or equal to our kth value. So whatever index this is, you would just say it's that index plus one number of elements because there's a 0th element, right? If this was index 5, you'd have 0, 1, 2, 3, 4, 5, 6 elements that are less than or equal to this kth value. And if C was, let's say it was greater than this kth value, so I'm not going to write it out, but you can just assume that I wrote kth value here. So if C is greater than our kth value, then that means that we don't want this guy, right? Because he's not less than or equal. But what we can also say is that, notice that all these elements out here are increasing. And if this guy was greater than, then that means that all of these are going to be greater than. So what we can do is just we can just ignore this entire row and just move into the next row. So again, if this guy was greater than, that means all of these were greater than down here inside this row. Let me just make another row right here. Okay, so we actually don't want these if our cell was greater than our kth value. Okay, and then what we're going to do is we're just going to increment, we're going to decrement our row to the next row. And we're going to say, okay, now we're going to do the same check. Is this cell less than or equal to our kth value, or is it greater than our kth value? And let's just say that hypothetically that it was less than or equal to our kth value. So what we'll do is we're going to count all this, just by checking the index and adding 1. And then what we're going to do is we're going to increment to the next column. So let me write another column over here. And now see our little index or wherever we're at is here now. And we're going to check, okay, now do we take all of these because they are less than or equal, or do we not want to count this because C is greater than? And depending on this, like that's how we're going to basically step through our matrix, like in some, like you can almost imagine like a staircase of how we're going to iterate through this. And eventually, we'll do something like this and we'll get to the end. Or we could do something like this. We might do something like this, or we could just go all the way like that. So I hope this was clear. If it's not, let me know in the comments. Okay. So let's get back to the code. So let's see. So we need, how do we want to start this? We're going to say int. So we want to start in our bottom left corner, so we could do it from the bottom left or the top right. It doesn't matter, because as long as we just need to be able to have like that decision where we know that in one direction it's increasing, or sorry, in one direction it's decreasing, and in this direction it's increasing, or vice versa. So so we want to start in the bottom left. So we're going to say matrix dot length -1, and we're going to say column equals 0. That puts us in the bottom left corner. And what do we need here? Oh, we need a sum, because we're going to count the number of elements that are less than or equal to this kth value. And we're going to say, well, row is greater or equal to 0 as we're incrementing through this, and column is less than matrix.length. We're going to check our conditions. So is the matrix at this row and column is this less than or equal to our kth value? And if it is, then we want to count this entire column. So this would be our column plus 1, right? Because let's just say this was, if this was 0, then we need to count at least one cell, right? Because 0 plus 1 is 1. We need to count that one cell. Okay, so let's see, if we counted, so now we just counted this entire column, so now we need to move to the next column. So we could just do col plus plus here. I know I could just do like a post increment right there, but I'm not trying to do anything fancy. So now this would be if it's greater than our kth value. So yeah, so this means that this is greater than, let me put some comments. This means that our cell is greater than our kth value, which means that we don't want everything in this row, in the rest of this row, or actually, yeah, this entire row, we don't want it, or wherever we're at. So we want to increment to the next row. Okay, or sorry, decrement to the next row, because we started at the bottom, we're working our way up. So we'll just do minus minus row. Okay. And I think we're good. We just return our count. Let me clean this up. Let's just remove some brackets. You know what? I'll turn this into a one-liner. Why not? Just put, and get rid of those brackets there. Okay, so I think we're good. Let's see what happens when we run it. Cool, I think this works. And of course I messed up. Where did I mess up? Give me a minute.
A few moments later.
Oh, I'm dumb. Okay, I made a little mistake right here. This shouldn't be col plus plus. It should be. Oh, okay. Now I see why. Okay, let me fix this, and I'll explain how I messed up. So, I do want to increment the number of. I want to increment to the next column here, but this should have been row, because if this column, or this cell is less than or equal to my kth value, then I want everything else in this column, which means I'm at index. The row is my index into the column, which is what I'm trying to say. So if the row is my index into this column, I need the index plus 1 or the row plus 1. Sorry for making that little mistake. Okay, let's run this again and see if it works. Okay, cool. That was my bug. So yeah, if anyone has any questions about why am I guaranteed or something to find this kth value or something in the matrix, I can explain it in the comments if you want, if someone has another doubt about that. Or anything. I don't know. Oh, but time complexity is just if this is, so this would just be log, so this whole thing is log n, sorry, log of the minimum, no, log of the max, let me just type it. Log of the maximum number in the matrix minus the minimum number in the matrix. And we have to account for whatever this guy is. That we said this was just log of m plus n, because in this m, and we could just say m is the number of rows, n is the number of columns. And I know this is an n by n matrix, but this would work even if it wasn't an n by n matrix. So this whole thing is just log of max minus min times, wait, did I just say log? O of m plus n. And this would be O of log max minus min. Sorry, I'm totally jumbling a little bit. Okay, so this whole thing would just be m plus n times log of max minus min. Okay. All right, sorry if that last part was a little bit rough, but I think you guys can see it. But anyway, yeah, if you guys have any questions, leave a comment or something. And if you want to see more, you can subscribe, and you can like the video if it helped. Cool, thanks, bye.